Humans are curious beings with big questions about life, like, what is the origin of the universe? What's inside a black hole? And how long can I push the boundaries of time and binge watch Netflix? In physics, there's one particularly big question we're trying to answer. What is the theory of everything? Is there a single theory that can explain all physical phenomena in the universe, from the smallest atoms to the largest galaxies? To answer our questions, we use physics as a tool to learn more about our universe. Like browsing the watch catalog for that perfect movie, we're using physics to find a theory of everything. If this theory was a film, it'd be an action, romance, comedy, and drama, all wrapped up in one. But right now, what we've got is a mystery. Now, one leading candidate for a theory of everything is a little flick called string theory. Here's why. There are two widely accepted ways to explain the universe: general relativity and quantum mechanics. Both have lots of evidence to back them up, but they conflict like quarreling siblings. General relativity explains the universe on a large scale. Conceptualized by Albert Einstein, it describes the cosmos as a smooth, flexible place. But quantum mechanics explains the universe at a really small scale, where everything is chaotic and highly unpredictable. When we put these two laws up against each other, the math clashes and falls apart. So what could unify these two and potentially unlock the theory of everything? Well, string theory. String theory suggests that when we get super small, about 10 to the negative 33rd power of a centimeter, we'd find that all fundamental matter in the universe is made up of one element: tiny vibrating loops, or strings. And all of the universe is a giant symphony of vibrations. Like playing a note on an instrument, the frequency a string vibrates at determines its properties as a particle. So if a string vibrates one way, we get an electron. If it vibrates another way, we get a quark. Plus, string theory accounts for a fickle variable in the theory of everything: gravity. We usually imagine fundamental particles as zero-dimensional points, but the issue is large-scale gravity doesn't work with these. Because the space between point particles would be so small, they're impossible to measure, and gravity needs measurable distance between objects to work. To fix this, physicists thought of something at a higher dimension than a point: a string. Strings bridge that distance needed for gravity. They could smear interactions between particles, smoothing spacetime on the chaotic quantum scale and unifying the big with the small. After scientists reformatted the equations to work for strings, they found that the math worked out exceptionally well. String theory accounted for gravity, general relativity, and quantum mechanics. It was the perfectly packaged theory. But there was also a catch. I should mention that people either love or hate string theory, kind of like pineapple on pizza. Even though the math of string theory is elegant, it requires an extra 7 dimensions on top of our usual 4 to work. These extra dimensions introduce things like potential parallel universes. Pretty cool, right? Like something out of the Avengers. But some physicists would argue that we save this stuff for the movies. Now, I know what you're thinking. So you're telling me string theory isn't the theory of everything? Well, the answer is we don't know. Yet. But string theory is undeniably a step in the right direction. By creating new ideas and theories, we get that much closer to answering our big questions about the mysteries of the universe. So until then, the search for that perfect theory of everything continues. And when we get there, you'll know where to find me.